Welcome. Today we're going to be learning about area and perimeter. Let's say I had a grass field and I wanted to figure out the perimeter. What I could do is just count these 1 unit boxes. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 units. However, there is a formula for finding the area. And what we're noticing is that these two long sides are similar, and then the two smaller sides are similar. The longer sides are what we call the length, and the shorter sides, where our goalpost would be on a football field, that's what we call our width. So if we know the distance of the longer side and the distance of the shorter side, we can use the formula, which is 2 lengths plus 2 widths is equal to the perimeter. So if I know that the length is 5 units, all I have to do is substitute in. Perimeter is equal to 2 lengths, 2 times 5, plus 2 widths, 2 times 3. Then we use our order of operations. 2 times 5 is 10. 2 times 3 is 6. We do our multiplying before adding. 10 plus 6. And altogether, that makes 16 units. Now, we don't know what they are, so when you don't know what they are, we call it units. Perimeter, with perimeter, the units are always to the first power. So the perimeter is 16 units. Again, perimeter is the fence around the grass. Area. Now, area. Now that we know, well, let's just take a look and keep drawing these boxes for our area. If we know, if we can see the boxes, all we really have to do is count the number of squares inside that grass field. So we'll notice I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 square units. Now, if we know the formula, instead of counting all the boxes, because imagine if there's 100 or 1,000 boxes, nobody wants to sit there and count 1,000 boxes. So let's try using the formula. The formula for a rectangle's area is length times width. Again, the long side is the length, so I'm substituting 5 in, and the short side is the width, 3 units. Now notice, we're really substituting in. I'm going to actually draw on top here. 5 units times 3 units. Now notice, we have area is equal to 5 times 3 is 15. Units times units is units squared. So area is always squared, and you will get docked points if you don't write the correct units. So when we have perimeter, it's always 16 UN. It's always to the first power. We don't write anything there. When we have area, it's always to the second power. And it doesn't matter what the shape is. Area is always going to be squared units. Perimeter is always going to be just units. All right. So let's try it. Let's practice it. Okay. I want you to take a look, and I want you to try the next one on your own. I'm going to give you the formula. So let's go. Pause the recording. Let me know. Let's see what you get. Now let's check our work. All right. So my long side, perimeter, is equal to 2 times 12 plus 2 times 7, which is 24 plus 14. 4 and 4 is 8. And 1 and 2 is 3. And so my perimeter is equal to 38. Now let's try our area. And remember, it's centimeters, and it's to the first power because that's perimeter. So the area is, we're going to do, our long side is 12 units times, it's not units, it's centimeters, times 7 centimeters, and that equals 84 square centimeters. So our area is 84 square centimeters and our perimeter is 38 centimeters. Remember, our perimeter is the fence and our area is the green inside. All right, let's try another. Go for the next one. Try using the formula. Now let's check our work. Add a little decimal here, so we have P equals 2 times 3 and 1/10 plus 2 times 2 and 4/10. Now I'm going to remind you, the way we multiply decimals is we just multiply like normal. And then this has, we count decimal digits. And so I move over 1 decimal digit because there's 1 decimal digit here. And so my answer here is P equals 6 and 2/10. We're at centimeters plus, I'm going to try 2 and 4/10 times 2. It's 8, it's 4, it's 1 decimal digit. So 4 and 8/10 centimeters. P equals, now as I'm adding my decimals up, I have to line them up. When we add decimals, here we were multiplying, right? Now we're going to add. We have to line up our decimals, right? 8 and 2 is 10, carry the 1. It's 10, 11, and it's 11 centimeters. Remember, it's to the first power. All right, area, here we go. A equals length times width. Now I'm substituting in 3 and 1/10 times 2 and 4/10. Remember, we're doing centimeters times centimeters, so area is, now, just doing double digit, 3 and 1/10. This time it's 2 and 4/10. So I'm multiplying like normal. It's 4, it's 12. It's 2, it's 6. 4, 4, 7. Now notice here, I have 1 decimal digit, 2. So I move over once, twice. Always start at the right. And so my answer is 7 and 44/100 centimeters squared, or square centimeters. All right, so let's look at, it's your turn now. Let's take some notes, okay? So let's look at our square, the perimeter formula for a square. If all sides are the same, then all we have to do is add S plus S plus S plus S. That means there's 4 S's, right? We're just adding the sides up with perimeter. And so our area would be side squared. Next one, let's go to a rectangle. Let's add this. I know this is not to scale, so I would draw that to scale, sorry. A rectangle, we're going to call that, oh, there it is. It's already expanded. Length times width. So it's like a square, but they're not exact same dimensions. We expanded that out, right? It looks like a square if I make one side a little bit longer, or one of the dimensions a little longer, then it becomes length times width. Our perimeter is 2 lengths plus 2 widths is equal to the perimeter. Area is A equals length times width. Pause the recording if you need to write the notes. Let's look at our next shape, a parallelogram. Okay? Starts out like a rectangle, right? But if I cut off a piece of that rectangle and then I add it to the other side, isn't that basically the same amount of area that's covered? Okay, one more time, let's take a look. We're going to take off a corner, I'm going to cut it, and I'm going to add it. So if I add it to one side and cut it off, we still have the same amount of coverage. So it's very similar to length times width, but now we call it base and height. And we don't use the slanted side. We use the height connects. We need a perpendicular. So the height is how high does it go to the top line? Take one base and go, how high can it get? So that's what we use for area. But over here with the parallelogram, we're just going to add up all 4 sides, right? 2A's plus 2B's equals the perimeter. And for the area, we're doing base times height. All right, now let's look at triangle. Okay, well, let's go from our parallelogram. We'll notice parallelogram is kind of like a rectangle. So we go from a rectangle to a parallelogram. Let's see how much of a parallelogram we need to get a triangle. If I draw a diagonal through the parallelogram, can't we say that that triangle shape is made by cutting the parallelogram in half? So if that's the case, then we can use our parallelogram's area, because it's covering the same amount of area, but half. So we're going to call it, remember, it's triangle is half of a parallelogram. So for the perimeter, we just add up all the sides, A plus B plus C. But for the area, it's important to know that inside, it only covers half the parallelogram. So the area formula is 1/2 the base times height. Pause the recording if you need to keep taking notes. Now, this is a little bit advanced, but I'm going to add it so you have a list of all the different formulas. So the next one is a trapezoid. And a trapezoid, sorry, it's kind of, the animations are off. The trapezoid looks like this. 2 bases that are different, okay? Basically, I want you to notice we've got our top base and our bottom base. They're parallel. That's how I know they're the bases. Okay, but they're different sizes. That's why I differentiate them as base 1 and base 2. So when I'm finding the perimeter, I just add up A plus base 1 plus C plus base 2. Okay, and the area, however, is area equals 1/2 the height. This is the height, the perpendicular. Okay, times base 1 plus base 2. So it's 1/2 the height, that's the perpendicular right here, times the quantity of base 1 plus base 2. All right, that was our trapezoid. Now that's pretty advanced, but I thought I'd throw these in there because at some point during the year you may be encountering them. Now the last shape that we're going to talk about is a circle. So for circle, we have a special name for the perimeter and we call it circumference. That's why it's circumference. That's the fence that goes around it. Now any other shape, we're adding up the outside for the perimeter. the circle, we're still doing the outside, but there's no sides to add up. So the way we find it is we take pi and we multiply it times the distance across. Okay? Now, in terms of the area formula is we take half of that distance across. So, when I have a distance across, okay, we call that the diameter. Okay? And if it's half of it, it's the radius. Okay? The diameter is the distance across. Half of it is called the radius. So a diameter is equal to 2 radiuses. Okay? So those, oops, I didn't mean to go there. So those are our area formulas. Pause the recording if you'd like to finish taking notes. Now let's put those formulas to use. We're going to go for our square. Okay? Now remember, a square, these little tick marks here, mean that the sides are all equivalent. So we can add up all the sides, 6 plus 6 plus 6 plus 6, or since they're all the same, can't we use this formula? P equals 4 times 6. And it's centimeters, right? So the perimeter is 24 centimeters. Let's try the next one, which is A equals 6 centimeters, and we're squaring it. Remember, area is squared. 6 centimeters times 6 centimeters is 6 times 6, 36 square centimeters. All right, pause the recording if you'd like to take some notes. Let's keep going. Now, pause the recording and I want you to try the next one on your own. Now let's check our work. P equals 4. The side measurement is 3.2. So we are doing 4 times 3 2/10 is equal to 4 times 2 is 8. I can do the multiplication over here. It's 8 and it's 12. I have one decimal digit, so it's 12 8/10 centimeters. I'm going to go back. We're about to... Okay, so here we go. So now let's take our base and our height. I'm not sure if I just got that. I noticed my recording went off. So as we look at more complex figures, we have to identify the base and the height. The way we do that is with the little right angle. And so the height is always that little dashed one. We're looking for the right angle right here. And it's always connected to the base. So there we go. All right. As we look at this, we're going to use this as our base, and this becomes our height. Okay? Now notice, my base is right next to that right angle, and the height is the dashed line. Sometimes they move the height, they draw a line for the highest possible point. It has to be perpendicular, and they just kind of extend them both out. So here, we're just kind of extending it all the way, and we're using the highest possible point to that. So, as we do that, this becomes our base right here. Base is the dark line, and this dashed line right here is our height. Okay? All right, let's try the next one. Again, same thing. Okay, we're going to just, this is my base. Let's use this as our base. All right, I'm going to use the little b, because big D means base area, okay? And now I'm going to just kind of draw it that way. Now I'm going from the highest possible point. So this is going to be my height, and this little piece is my base. Maybe the PowerPoint will look a little bit better. All right, so let's try it. Now, remember, for our perimeter, we add up all the sides. Okay? So I've got two sides, right? If this is the parallelogram, remember, this side is the same distance as this side. And the short side is the same distance as the short side. So we are doing 2 times 9. And let's do plus 2. Let's make that. Perimeter is equal to 2 times 8. And now what we have is it's 18 plus 16. So our perimeter is 34 inches, and it's perimeter, so it's to the first power. Okay, let's try our area now. Okay, area equals base times height. So the base, we're looking for that perpendicular with that right angle. The base is 9, and the height is not the slanted 8, but the perpendicular dashed line 5. So we're really just multiplying 9 times 5. That would make 45 square inches. All right. Now, you try it. Yeah, we always put the square outside of the units, not squaring the number. That would be wrong. We could write it in these 3 ways that are circled, but we may not put the square outside of the 45. All right, I'm going to do the first one. And now we're just looking for area. Now be careful, because if we're just looking for area, they're throwing a number in here to trick you. So remember, area equals base times height. And in this case, how do I identify my base and height? I'm looking for that right angle. So we've got our 10 and our 8. Those are the numbers. 8 times 10, and it's units times units. If they don't list units, then you write 80 square units. Okay, pause the recording and try the next 3 areas on your own. Now let's check our work. So on number 2, we're going to be multiplying base times height. So that would be our 8 times 14. Number 3 is 12 times 9. So that would be 108 square units. Number 4, our base, remember, our base isn't identified, but remember, parallelogram, this would be my base right here. And what's parallel to it, the same size, same shape, is that 13. So we're using 13 and 2 5/10. And you should have gotten 32 5/10. All right, sometimes, look what they're doing. They're giving us a base. They're not giving us a height. They're throwing a trick in at you and giving you that slanted height of 10, that diagonal of 10. But what they are giving us is the area, so why don't we substitute in? If the area is 135 and we know the base, let's substitute in what we know. 135 times 15 times h. Well, to get that h alone, I have to do the inverse operation. I'm going to be dividing both sides by 15. And now what we have is h is equal to 9. Now remember, the height is in inches, not inches squared. The area is square inches, but the height and the base are all at inches. So it's 9 inches. All right, let's try 2 more. Pause the recording. Let's go. Finding more area. Area equals. Now, what I want you to notice is that our units are different. Okay? So, 1 foot is 12 inches. So, here we go. So, we've got to convert them to the same units. Okay? Pause and try the next one on your own. Okay, so we've got to convert our meters. We'll convert that to centimeters. So now what we're using is 40 times 16. And that makes 640 square centimeters. All right, I think we're going to stop on triangles, but let's finish these up because we've talked a lot about that we need the base and the height. Now, what they do is, remember, the sides are all used for the perimeter. So when we have our perimeter, right, we're just adding up our sides. 6 plus 8 plus x. I don't know what x is. Simplify that. That's x plus 14 centimeters. Now, in terms of our area, we're using our area formula. Remember, a triangle is half of a parallelogram. So I'm doing 1/2 the base, which is 8, and the height we can identify by the dashed line connected to the 1/2, 8 times 4. Or you can do 1/2 of 8, which is 4 times 4, 16, or 1/2 of 32, which is 16. And since it's area, it's centimeters times centimeters, so centimeters squared. Okay? All right, let's pause the recording and try the next one on your own. So here we go. The perimeter, we're going to add up all 3 sides. Perimeter equals 6 plus 8 plus 17. Add it up, 31 square centimeters. Area. Pause the recording if you haven't done it and do it on your own. Now let's check. Area is our base. Remember, it's 1/2 base times height. The base is 6. Because if I draw that out, and then the height would be that connecting dashed line of 7. Now we can either do 1/2 of 6, which is 3, or I can multiply 6 times 7 is 42 and do 1/2 of 42. 21 square centimeters. Let's try a few more triangles. Okay, I'm going to do the first one. This time we're just doing area. 1/2 base times height. So 1/2 of 35 is about 17.5. It's not an even number. Pause the recording and try the next 3 on your own. All right, let's go. Let's check our work. Number 2. Remember, we're looking for that right angle. That's what identifies our base and our height. 1/2, 5 times 12. I personally like to do 1/2 times 12. 2 divides into 2, right? 2 goes into 2 once. 6 times 5 times 6 is 30 square units. Okay? But you can do 1/2 times 60, which is 30. Okay? Number 3, your base is 6, your height is 8. Number 4, your base is 6, your height is 6. Okay, sometimes, this will be our grand finale. Sometimes, I think, oh yeah, let's keep it. Sometimes we can take a shape and actually find the area of both shapes and put them together. And so what we see here is the first rectangle. The first shape we see is a rectangle, and the other shape we see is a triangle. And so if we find the area of the first shape and we add it to the area of the second shape, we can find the area of the irregular shape, or this trapezoid. So the first shape is this rectangle here, right? And so we know the dimensions because over here it's 10 and here it's 4. So I'm substituting in 10 times 4. And then we have a triangle, right? Which is right over here. Okay. And they've added, it's a little bit tricky here because they're kind of adding some strange dimensions in here. Well, we know the base is 3, right? And we have to do that 1/2 for a triangle. Remember, it's 1/2 base times height. So I'm doing 1/2. We know the base is 3. Now the height, it's not the 5. It's actually the 4. So, because if this is 4, this is 4. They're parallel, right? So there we go. So I have 40 square units. I guess it's meters. And here we have 1/2 of 12, which is 6 square meters, which makes 46 square meters. Now, so that is our lesson for the day. I chose to skip the circles and the circle practice because it seems like it's a bit much. If you want to sign off, you may, but I'm going to actually add it to the recording, just not add it to the class. So the official class is not doing it, but circles and trapezoids.